is differentiation. In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. The concept of derivative is applied in all field of studies, which is biology, for example, changes in number of bacteria in a culture. In business, change of profit per year, and lastly for engineering, optimization, maximum strength, and minimum cost. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time called velocity. The opposite of finding a derivative is anti-differentiation. If we use y equal to fx to indicate the independent variable is x and the dependent variable is y, then some common notations for the derivative are as follows: fx prime equal y prime equal dy per ds equal df per dx equal d per dx fx equal capital letter D fx equal dx fx. The symbols d and d per dx are called differentiations with operators because they indicate the operation of differentiation, which is the process of calculating a derivative. There are many of techniques of differentiation, which are constant functions, power functions, sum and differences, product rule, quotient rule, and the chain rule is one of the techniques differentiations.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nakiri Najmi bin Muhammad Rasul with the metric number 2021486848. So now I will continue this presentation with the related rates topic. So guys, what is related rates? Related rates are so important because there are so many real world applications of it, like a snowball melting, a ladder falling, a balloon being blown up, a stone creating a circular ripple in a lake, or two people, boats, planes, animals moving away from each other at the right angle, and not to forget the ice cube in your refrigerator at home. So one of the hardest calculus problems that students have problem with are related rates question. This is because each application question has a different approach in solving the problem and requires the application of derivatives. However, once you know these 6 steps, then you should be able to solve any calculus related rates problem that you like or you're facing for. Here are the following steps in solving a related rates question. Maybe this can help you to answer some of the questions. So first of all, if possible, drawing a diagram to help visualize the problem. Number 2, express the given information and rates, which is look for units with time in the denominator. Number 3, express the asking rate, which is look for the phrases such as how fast, at what, find the rate, or anything else. Number 4, write an equation that relates the various quantities of the problems. Number 5, differentiate both sides of the equation with the respect to time using the chain rule. The numbers. And number 6, which is the last or the final step, is substitute the given information into the differential equation and solve the asking rate. So I think that's all. Let's take a look at a few calculus practice problem using this step.
A cube-shaped container is filled with water and have been put in the freezer. The volume of the container is 125 cm3. The water freezes into ice at the rate of 15 cm squared as power of -1. Find the changes in the length of the sides in cm as power of -1. As we all know, the cube has the same sides, so we can consider the sides as x. So the area of the cube is 6x squared. Thus, we can differentiate the area with the equation dA per dx. When area is being differentiated from cx squared, it will become 12x, and we can replace x equals to 5 as we already find the sides. So dA per dx equals to 12 times 12 times 5 equals to 60, and dA per dt, which is the rate of the water freezes in ice, which is given 15 cm squared as power of -1. So we search dx per dt by expanding the equation of dA per dt equals to dA per dx times dx per dt. We can put the information that we achieve from above details with 15 equals to 60 times dx per dt. Therefore, dx per dt equals to 15 per 60, and dx per dt equals to 1/4 cms power of -1. So the water freezes at the rate 1/4 cms -1. That's all from me. Thank you.
So for question number 2, a spherical balloon is being inflated at the rate of 8 cm³ per second. Determine the rate of which the radius of the balloon is changing when the radius is 10 cm. It is given that the rate of the balloon being inflated is 8 cm³ per second, which means dV over dt is equal to 8 cm³ per second. The formula for the volume of the balloon is 4/3 pi r³. So, in order for us to search dr over dt, which is the rate of the balloon is changing, we need to use chain rule by having dr over dt is equals to dr over dv times dv over dt. In order to get dr over dv, we have to do dv over dt first, because we already given the volume of sphere formula. So we differentiate the formula of the spherical balloon and we will get 4 pi r squared. Now we have the value for that is needed to compute the value of dr over dt. So we put in the information as dr over dt is equals to 1/4 pi r squared times 8³ per second. The value of dr over dv is 1/4 pi r squared because the equation is coming from dv over dr that is have been inversed. So we can get the final answer by multiplying the data, and the final answer for dr over dt is 0.0637 cm per second.